We'll see one more problem. This is related to programming syntaxes and some problems related to that programming syntaxes. First one is, sir, what about these problems? We never saw this kind of problems. Don't worry. So usually you can understand these problems. Okay. First you understand the syntax and let me explain what is the problem with this syntax. Then automatically you can map it. Okay. They are not so big problems. First one is malloc of 5. Malloc, when you write size of int, it gives what? Number of bytes required to that integer. But if you simply write integer 5, then it means it gives that many bytes. So malloc of 5 gives 5 bytes. Let's say 1, 2, 3, 4, 5. Doesn't matter for us. Like, this problem does not depend on that. Now starting address, let's say 100. Then we are storing that 100 into m. That's why m is pointing like this. Now suddenly what you did in the second line, you made m value to null. That's perfect, not a problem. But what about this memory? We have only one pointer which was pointing to that memory. Suddenly you moved from that pointer to another place, correct? That location to another location. Then definitely no one can access this memory, right? Then you are wasting the memory. But syntactically it is right. There is no problem, but you are wasting the memory because there is no other pointer which is pointing to this memory. Usually it happens if you are not careful. Okay, so it's like allocating the memory and immediately forgetting the starting address, right? Then this is called memory leakage, right? So you should avoid memory leakage. So what is the rectification to this? So when you really want to make m equal to null, then before that please free m so that that memory will be deallocated. You did not do that free of m, right? So add free of m here. Then this will be the perfect one. Now I would like to tell you that this problem is nothing but memory leakage. That's why lost memory. We lost the memory, right? So x is mapped to 3. Let's try. So there is either C or D is the correct answer. We'll see y. Y is free of n followed by n cap value 5. You should understand one thing. Whenever we are doing free, before that there should be some dynamic allocation. Let's say this is the dynamic allocation and something. Starting address is 100 and you are holding now that starting address. Okay. Then suddenly free of n happens. Then what happens? This memory will be deallocated, but 100 will not be erased from you. That's about C programming. C programming design is very simple, so that when you do free, only memory will be deallocated, but the content of n will not be modified. Then what can happen is, if you refer n cap value, we'll see this syntax. Usually we do this kind of syntax in structures. Okay, so go through structures videos, then you will understand. So n cap value is nothing but it's referring value at some 100. That means we are using 100 again and we are going to 100 cap value. Okay, so value is some field of that memories. Okay, then 100, actually it's not about value but it's about 100. Referring 100 again is definitely a problem. What is that problem? Dangling pointer problem. So this, in the high level, you can understand this like this. You have deallocated the memory but still you are accessing n, but n is now having that deallocated memory's address. That's why this will give you error. What is that error? So runtime error. And the famous problem which is related to this one is called dangling pointer. This is called actually dangling pointer problem. Okay, so that's why answer is using dangling pointers. Here you are using a dangling pointer. Now we'll see Z. Z is character pointer p followed by value at p equal to a. Let's try to understand this with pictorial representations. Let's say p is a character pointer. Let me remember it. Then after this line, what happens? Some p will be created but no initialization for it. Then it contains garbage value. Remember it. Then value at p equal to a. Okay. What is star p? What is p? Content of p is garbage value. Then you are referring star garbage value. Whenever you derefer garbage value, that means you are going to evaluate this garbage value. That means we are treating garbage value as an address and we are going there. Then definitely that would give you an error, and that error is nothing but, what's the problem here? You have not initialized p and still you are using that content. That's why it is a problem called uninitialized pointers, right? So using uninitialized pointers. Answer is of z comma 2, right? So now let's see the correct answer. X should be mapped to 3, correct, correct. Y should be mapped to 1, correct. So option D is the right choice. We don't have other option. And Z should be mapped to 2. Yes, perfect. So option D is the right choice for this problem.